Welcome back to Blueprint Bootcamp Tournament Edition. Today we're going to be doing drawing number 22, the tractor bracket, so stay tuned. Alright, so today on Blueprint Bootcamp Tournament Edition we are going to be doing drawing number 22, the tractor bracket, and this is a very realistic real-world part. I know sometimes we get caught up doing some practice assignments and it's just a skills check. But this is like a 3-point link on the back of a tractor, something to raise up your back end implements. So I do like this drawing today for a variety of reasons. We'll jump in and we'll kind of show you what's going on. So in Onshape, if we're looking at our drawing, you will see that our unit system is in inches. We're going to be measuring in pounds, and of course time is in seconds. Plain carbon steel, it's a tier 3 part, and it's called our tractor bracket. We come up here and look. Our tolerance is plus or minus 0.01 pounds, so we'll pay attention to that. We also get some Toby notes up here. These yellow fillets are going to be a 1/4 inch radius, and what's cool is all these measurements are actually fractional measurements, which is exactly how I would get something given to me in the shop. Unfortunately, most drafting programs don't really have an easy way to put it in unless you do, so like for this one, for example, 2 3/4, unless you know that off the top of your head, you'd have to do 2 plus, and then in parentheses, 3/4, close parentheses, so you would be able to get that kind of algebra done. And Onshape does that, that's cool, but this is a good exercise in learning why you need to go from fraction to decimal so well and fast and efficiently. So we go up here, we'll take a look at our part. Essentially, this is how we're going to draw it today. We're going to draw 2 big circles. We're going to draw a line that is tangent to both of those circles. That needs to be 6 1/8 apart. This one out here is going to have a radius of 3/4. So if we were to look here, we can get our information in kind of 2 spots. So yeah, this is radius of 3/4. But if you look down here, you get the diameter of 1.5. So if your program gives you the option to put things in radii, that's how you should do it. Otherwise, go down here. So we're going to do 1.5 for here, and then 3 1/4 on this side, or a radius of 1 5/8. But 3 1/4 is a lot easier to put in on this. And you'll see that we have 3 different steps. So we have one that goes up 1.5. We have one that goes up 3 inches, and we have one that goes up 3/4. So we are going to use that multi-extrude feature today to kind of show that off. It can be a little clunky at times if you don't practice it enough. And honestly, selfishly, I'm trying to make myself do that. Here we have a through hole of 7/8 all the way through. And over here, we have our counter bore, which is 2 3/4 to the counter bore. That only goes down 1/2 inch, and then all the way through is a 2-inch hole over here. So let's go ahead and jump on into our drawing and we will get started. All right, so once we are in Onshape, we're going to go ahead and select the top plane, press Shift and S to start our sketch, N to normalize, and P to hide those planes. We're going to start with a circle, center point circle, and that needs to be 1.5 centered on the origin. Inside of that, we're going to do another circle, and that needs to be 7/8. So 7 divided by 8 works here. When we don't have a whole number, it's a lot easier to just type in the fraction. But if you notice, after I type that in, it tells me, it actually translates it to decimal. So 7/8, lock that into memory, is 0.875. If you ever need to use that again in the future, I recommend getting used to fraction to decimal conversions. It's a little hard. I know most of the time if we look at our drawing, this is pretty much how you're going to be given a print in the real world. If it's from somebody who isn't an engineer, a lot of stuff we do in ag, it's read with a tape measure. Our tolerances are a lot smaller, and this is what you're going to get. Obviously, if you go to a machine shop, everything's going to be in millimeters, or it could be in inches, but it'll be to the 1,000th of an inch, and you'll have a lot of tolerances and stuff. But something like this, it's kind of going to be used with prefab pipes, and you're going to be probably making just a plate here in the middle. So it's going to be one of those things that you want to make sure you pay attention to when you're doing this. So 875, you can just type in 7 divided by 8 and that will work. So next step, we are going to go up here We're going to track right to the top of our circle, and we're going to key out to the side. And I'm going to draw another circle that comes from the center. We're going to track from the center here. Just give it a little bit of space, and that needs to be 3.25, so 3.25. Next, I'm going to tell that to tangent by pressing the letter T on my keyboard and tangenting those two lines together. And next, I will press the letter M to trim off that excess up top. I am now going to do the D for dimension, and I'm going to select my center point, my origin, and my center point of this circle, and I need to tell that those need to be 6.125 away from one another, or 6 1/8. And so we have our distance. Notice my whole drawing is completely defined. We know that because everything is black. Next thing I'm going to do is press P to turn my planes back on. And I'm going to select the mirror feature. So if we look up here, the mirror tool, I have a whole video on how this thing works. And this is honestly probably my most used tool when it comes to symmetrical designs. So I'm going to click mirror, and it's going to ask me to select a mirror line. So the reason we turned our planes back on is because we're going to use that front plane, and we're going to mirror over that. So now it's asking me entities to be mirrored. I'll just select that line, and now we have a closed shape, so we are good. At this point, I am now done with my shape. I'm going to turn those planes off because it's going to get a little messy. And we're going to use the multi-extrude custom feature. So again, I will put that in the description so you can get that. But this is how this works. So we click add part. We're going to select this part, and it's going to tell me a sketch region. So I'm going to select that region. My length, that one needs to go up 1.5. So we say okay. Add part, sketch regions. Our next part needs to go up 3/4. And we'll say add part. We'll click the sketch regions part, and our last part here needs to go up 3 inches total. So we'll say okay. And now you'll see we have 3 extruded parts. Now we could have done that and extruded each one along the way, but this multi-extrude feature kind of makes things really quick, especially when you have different depths and varying things. It's a little less keystrokes, and it kind of all is done in the same feature, so that's kind of nice. Next thing we're going to do, because they are separate entities, now we're going to have to do the Boolean feature. So we'll say union. I don't want to keep the tools, and now we have our shape like so. Next thing I'm going to do is I'm going to select this top face, and I'm going to use the hole tool. So here I'm going to select a mate connector, and I'm just going to pick the top of that circle. We're doing the counterbore. Our counterbore hole is actually 2 inches all the way through. Tab, 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 all the way down here, 2.75 for our counterbore, and that counterbore again goes down 1/2 inch. And you'll see that this, I really like this feature that they added in Onshape with this hole tool. You can they give you this exactly the way you would get it in a print. So you see diameter 2 through, counterbore 275 down 0.5. And if we look at our drawing, again, that's how you would be given it. So you'd see he kind of broke it up a little bit on this one, but 2 3/4 counterbore, 1/2 inch counterbore depth, 2 inch through. So real world kind of coming into play here, and we'll say okay. Last thing we got to do is round our corners, shift and F, and those are going to be 1/4 inch. So I'm going to click here and here. And if you're worried about doing that fraction to decimal, just literally do 1 divided by 4, and it will translate it for you as well. So we have that there. We'll say accept, right click, assign material. We'll pick our custom library, and this is going to be made out of plain carbon steel. Accept it, and we come over here, get our weight, and I have a weight of 6.512 pounds with a tolerance of plus or minus 0.01 pounds. You can have anywhere from 6.50 all the way up to 6.52. So 6.51 is what I got. You can go down to 650 all the way up to 652, and you can make this part. So pretty cool way to do this thing. I'm going to go ahead and delete the timeline, and I'm going to back up a little bit. I want to show you how you could do this from a without using the hole feature. So if we were to come up here back to my original sketch, I would need to draw a 2-inch hole in the center, and I would also need a 2 3/4 2.75 hole as well. And the way to do this, it's going to just be a lot of extrude. So this one, extrude, this part needs to go up. Again, let me pull my drawing back. Needs to go up 1.5 right here. 1.5. We'll say accept. Let me rotate that a little bit. And then this part I would need to extrude up 3/4. And then this part would have to be extruded up to 3, but then I would have to do that counterbore the other way. So it's kind of a tricky thing to do, because then I would actually have to draw that. At this point, it would be better to draw this sketch up here. And because we already drew it, we could reuse that piece, and then we would extrude down. We do a remove cut of 0.5, and then we would get our deal. Same thing, Shift F, round those corners to 1/4, and assign our material. Plain carbon steel, get our weight, and we get 6.512. So same exact process, just our feature tree is a little bit longer. And if you're doing the same thing and that multi-extrude custom feature works for you, that's kind of going to be the best way, in my opinion, especially if you're doing this for competition. It's going to be speed that gets you there faster. So if you're the guy who's sitting there and doing 3 different extrudes, 4 different extrudes, because you got to do a cut extrude as well, how much time are you saving using the multi-extrude? You could end up winning the whole thing over using that custom feature. So that's going to do it for us today. Hope you guys are learning lots. This is going to be our, I know last week I talked about if you guys wanted to do a summer kind of workshop type deal series. I'm still kind of brainstorming that, trying to see, do we want to focus more sheet metal? Do we want to focus on 3D printing? We want to do something similar to my CAD vent calendar, where I was giving you just random stuff to work on to keep your skills brushed up. Let me know down in the comments. Send me a message, send me an email, whatever you think. But go ahead and make sure you guys are watching these videos. We're like this close to getting to be able to put ads to where I can start making money off of this thing. So if you guys are doing nothing over the summertime and you just want to pull up a playlist, turn my videos on, and let them play. I need that watch time. So anything you can do will help. I think we should have been there already, but because I show you guys stuff at school, it all counts weird. But anyways, enough talking about business stuff. But the more you guys watch the videos, the more it'll help. We can start pulling more cool stuff out like this. So thank you guys again if you've been with us from the beginning, and I hope you guys have a good summer, whatever that means to you. Hotter weather, vacations, time off, whatever. But you guys have a good day. You guys take care.